You just received a message, probably over Wi-Fi. Wireless, right? Or maybe it came from a satellite up there. Wrong. It came from here, from a cable, at the bottom of the ocean, 26,000 feet deep. The internet is not wireless. 99% of everything that crosses continents, your videos, your emails, your live streams, travels through optical fibers the width of a human hair, buried on the seafloor. Oh, and that story about sharks eating the internet. Less than 0.5% of all failures. The real villain. Ship anchors. The internet doesn't go down from teeth. It goes down from iron. But here's the real question. How do fibers the width of a human hair carry 5,000 4K movies per second underneath entire oceans without the light dying halfway through? Welcome to the invisible backbone of digital civilization. Let's start with scale. The 2 Africa submarine cable, a metal-lead project, is 28,000 miles long. Earth's circumference, about 25,000 miles. This cable goes around the planet, and there's still cable left over. It starts here. Inside, ships like the Leonardo da Vinci. Tons of cable coiled in tanks that look like the womb of some cybernetic creature. But what is this cable exactly? Think of it as a technological onion. At the center, optical fiber, 125 microns, the width of a human hair. This is where your data travels. Around it, petroleum jelly for water protection, a copper tube carrying 15,000 volts, polycarbonate, galvanized steel, extruded polyethylene. In the open ocean, the cable is about as thick as a garden hose, 2/3 of an inch. Near the coast, where anchors hunt, 4 inches, armored like medieval plating. And the numbers? 200 terabits per second of capacity, 26,000 feet maximum depth, $300 million of investment, 25 years of projected lifespan. Down there, in the abyssal zone, there's no sunlight, no sound, only pressure. 800 atmospheres crushing every square inch. And this isn't one cable, it's hundreds. A planetary nervous system pulsing information between continents in real time. But there's a problem. A physics problem. The light dies. When you send a message from New York to London, it travels as light. An infrared laser pulsing inside that hair-thin glass fiber. But light doesn't travel forever. After 62 miles, the signal weakens so much it becomes unreadable. Attenuation. The light literally goes out. New York to London, 4,100 miles, 66 times the limit of light. Without intervention, your WhatsApp would die in the middle of the Atlantic, swallowed by physics, by darkness, by the absolute silence of the ocean. So, how do you solve this? The solution has a name: optical repeater. Every 30 to 60 miles, there's one of these. Buried on the ocean floor, a stainless steel cylinder about the size of a large tuna. Inside it, the fiber is doped with erbium, one of the rare earth elements. When weak light arrives, pump lasers excite the erbium ions. And here's the magic. They clone the photons. They amplify the signal without having to convert light to electricity and back to light. It's as if the light is reborn every 60 miles, 66 times between New York and London. But there's a detail, a brutal one. These repeaters need power. So, wrapped around the glass fibers, runs a copper conductor. 15,000 volts of direct current, fed by stations on land, on both sides of the ocean. The internet isn't passive, it needs outlets. On the sea floor, this isn't a cable, it's an active electrical machine crossing abyssal zones. But engineering isn't just physics, it's geography. 17 to 30% of all global internet traffic passes through here, through Egypt. To connect Europe and Asia, the shortest path is through the Suez Canal and Red Sea. And at certain points on the Egyptian coast, dozens of vital cables run side by side in terrestrial trenches. A single runaway tractor, a landslide, and India disconnects from Europe instantly. The most advanced thing humanity has ever built can be destroyed by a poorly thrown anchor. And when that happens, the most insane operation in modern engineering begins. First, you need to know where the cable broke. The tool is called an OTDR, Optical Time Domain Reflectometer. Imagine shouting in a tunnel and calculating the distance to the wall by how long the echo takes. Engineers fire a laser pulse into the cable. When the light hits the rupture, it reflects back, and they can locate a break 2,600 miles away with accuracy down to a few feet. Then you send a ship. They don't use divers. It's too deep. They use grapnels, steel grappling hooks. The ship launches the hook and drags it across the seabed until it snags the cable. If the cable is buried, they use an underwater robot. Water jets unearth it. Mechanical arms cut it. The cable is cut down there, and the ship pulls up one end at a time. The ends reach the deck, which is soaked, battered by wind and 16-foot waves. How do you ensure splice quality? By doing the repair inside a pressurized container, an oasis of cleanliness in the middle of the storm. An arc fusion splicer melts the glass that forms the optical fiber, joining the two ends. Is there signal loss with the splice? Yes, but it's in the range of 0.01 decibel, which is practically nothing. The splice is protected by a steel case called a universal joint, capable of withstanding 800 atmospheres of pressure. But there's a problem. When you cut the cable and pull both ends up, it became shorter, right? So you add an extra piece. When returned to the seafloor, it descends straight and forms a loop like a U or the Greek letter omega. A permanent scar on the seafloor. Total cost, over $1 million. Repair time, weeks. If a fishing boat was at fault, their insurance goes bankrupt, and the internet comes back. But the engineering doesn't stop. Today, engineers are developing hollow core fiber. The center is no longer glass, it's air. Light travels almost in complete vacuum inside a submarine tube. The holy grail of optical engineering. And there's more. Scientists discovered these cables are sensitive enough to detect earthquakes. New cables are being equipped with sensors at every repeater. SMART cables. The infrastructure that brings your memes can now also save lives, detecting tsunamis before they reach shore. We've transformed the telecommunications cable into a giant planetary sensor. The internet is not wireless. It's not magic. It's a nervous system of glass, steel, and light, crossing the ocean in absolute silence.